So the law of cosines, in order to do the law of sines, you have to always have at least one side and one angle across from each other. So what do we do if we don't have a side and an angle across from each other? We have to use the law of cosines. Okay, so the law of cosines allows us to find the remaining angles or sides of a triangle if I don't have a side across from an angle. So to begin with, the law of cosines works like this. It's very similar to Pythagoras' theorem to begin with, because I go a squared equals b squared plus c squared. But that's where it ends. Okay? So now I go 2bc times the cos of the angle across from the side that I'm looking for. So this is what we call the law of cosines. Okay, so most of you have seen this before. Alright, if I was looking for b squared, what would the equation be for b squared now? A squared plus c squared minus 2ac cos b. Good.
That's just subtract 2, not negative 2.
That's subtract 2. Yeah. Okay, now we'll get to that in a second when we talk about angles. Okay, so if I'm looking for a side, that's how the law of cosines works. Now, if I'm looking for an angle, we still use the same equation. The only thing is I have to arrange the equation so that I get cos A equals. So let's have a look and see how that works. So I've got a squared equals b squared plus c squared minus 2bc times the cos of A. So I want to arrange it so that I get cos A by itself. Okay, so what's the first thing that I need to do to get the cos A by itself? So the first thing I'm going to do, alright, you're still using the same bedmass rules. Brackets, exponents, okay, those types of things. But the difference between that and this is I've got to solve for A, so I always start with addition and subtraction first. So I need to isolate. So the first thing I do is I subtract b squared and c squared. So I go a squared, subtract b squared, subtract c squared, equals. Now at that point right there, it's better that I understand that this turns from a subtraction into a negative. Because on your calculator, that's going to make a difference when you punch it in. Now, I've got minus 2 times b times c times the cos of A. So what do I do to get cos A by itself? That's right. Divide by whatever's in front of it. So I go a squared minus b squared minus c squared divided by minus 2bc. And then what do I have to remember? Because I'm looking for A, what do I have to do to finish this question off?
Times it by cos.
Not multiply. What do I got to remember to do when I find angles?
That negative cos function.
Right, second function cos. Inverse cos to get A by itself. So I wouldn't write this down, but I'm going to show it to you. So I have that. Now, if I was punching that into my calculator, I would do that first. Then I have a bracket. Then I go a squared minus b squared minus c squared. Close the bracket, divided by, open bracket, minus 2bc, bracket, bracket. So those would be the keystrokes I would use on my calculator to get A. And I can fairly easily do this all in one fell swoop. Okay, I can do this all in one motion, punch it all in at one time. Alright? Okay, so let's just put it into practice now. Page 95, write this in your book. So, let's find all the missing sides and angles that I have here. So what am I looking for? What am I missing?
Side
Side
B,
B.
angle A and angle C.
Angle A, angle C. Okay, so let's use all our resources. Now what you're going to find is you'll need your law of cosines to start this question, but more than likely you'll use the law of sines after that in order to solve the rest of the triangle. So we basically just have to focus on the cosine, and then we go back to what we did yesterday, which is the law of sines. Alright, so I'm looking for side B. B squared equals 100 squared
plus 50 squared.
plus 50 squared.
Take away 2 times 100 times 50 cos 155.
Very good.
Don't you have to?
And then, yeah. And at the very end, well, I'm going to do that right now. I'm going to square root it to get what B is. Okay, so I want everybody to punch this into your calculator so that I know that you can do this. So punch that into your calculator. Three.
844.
Use it again, so we'll put that. Okay. Anybody not get that answer? Anybody not get it? If you don't, put up your hand so I can just look at your calculator work, okay? You alright?
Mine won't. Every time I go put the bracket around the 100, it goes and puts it to 2100.
Don't press equal between.
I never.
Okay, let me show you, let me try this again. Okay? So, I want you to punch in as I write. Okay? So the first thing I want you to do is your square root. Did it open a bracket?
No.
So that's the first thing I want you to do is open a bracket. In fact, you need to open 2 of them. Like that. Okay? Alright? So now I have
100 squared.
100 squared
Plus 50 squared.
plus 50 squared.
Subtract 2.
Subtract
2.
2
Times 100.
times 100.
Times 50.
Oh, let's put 0. You know what? I put 1 extra in here, but whatever.
Times 50.
Times 50 times the cos. 155. Close, close. I got 1 too many brackets in here, but it'll still work.
My thing doesn't open up the brackets in the beginning.
Sorry?
Like, if I
That's why I'm telling you to put brackets in there.
I wasn't around.
Okay, so you haven't done it yet. Just wait. Does it put brackets on the 150? Does it, when you hit cos, does it put brackets on it?
Well, I just can't do the square root and then put the bracket.
Why not?
It won't work. Like, can we do that after? I'll show you.
Let me see.
So I started
I just
off.
need to see. Okay, so you can't do that. So yours is. All right. Yours is going to be a little more difficult to work with. So that's why I would, if I was you, I would get a graphing calculator from the library. Okay, but I'm going to show you what your keystrokes have to be. So follow me again. Okay, 100 squared plus 50 squared minus 2 times 100 times 50. Seth, put it on the back shelf and shut it off. Times 155 cos equals square root.
Yeah, I got 146.
That's the correct answer. Okay, now, what the problem is your calculator, you gotta kind of put your numbers in and then reverse it. Okay? So, that's how I would have to do all of that if I was gonna do it at one time. Alright, Eli? So those are the keystrokes, but like I said, I would probably try and get a graphing calculator so that it can put in the way it looks. You make fewer mistakes. Okay? But it works. Alright, so let's go back to this now. So I've got this guy, 146.844, right? Okay, so let's find out what angle A is. Okay? So angle A, I'm going to use my sine law. What's the side across from A? 50. Sine 155 over 146.844. I want angle A. So again, the reason I strongly suggest we go to 3 decimal places is we have to use these numbers again. And if we round it off, then you keep getting further and further. Each time you use it, you get further and further from the correct answer. All right? What did you get?
I got 8.274. I don't know if that's right.
That's right. It would be, you think it's too small?
It's a pretty little angle.
It is a pretty small angle.
Oh, never mind. The base angle is
Exactly. Right? Okay. Everybody get that one? Eli, can you do that?
I'm working on it.
Okay. While Eli's working on it, let's find out what C is.
I keep getting 0.1439.
Second function sine.
Oh, yeah, I know the zero.
16.726.
16.726 degrees. Now what should I do?
Add all the angles up.
Add the angles up, and if they equal 180, I probably have the whole question right. And they do. Again, this is that unit that you can guarantee everything's right. At the very end, you can check it so that it makes sense. All right? Eli, how you doing?
I got it.
You got her? Okay, you know how to use the calculator to do the signs now? Okay, good. Any other questions about that? I basically covered the whole basis except for maybe I'll do one angle one with you. I'll do the second second example. Any questions about the sine one here? Or not sine one, but the first coast one?
We're doing the one where it's like you don't have any angles, you just have
Yes.
poles out.
I'm going to do that right now. Okay, any questions about this guy? No? Shay, you got it written down? Okay. All right, let's have a look at the second example. C-A-B 2014-15. Okay. So, can I use the law of sines here?
No.
How come?
So it requires an angle.
I need an angle, and I certainly need an angle across from a side. So I can't use it. So I got to use my law of cosines. Okay, which one do we want to find first? Which angle? Okay, so the cos of A then is equal to. So I'm going to do this without looking at the equation. So I'm going to show you how, just a second. I'm going to actually write it out with letters first, and then we'll plug it in. So you're right. Okay, so when I'm looking for the angle, the very first side that goes on the board is the side across from the angle. So that means A squared goes there. And then it's minus B squared minus C squared over negative 2BC. Just like that. Okay? So, what's that?
You have to multiply it by cos. Oh, no, never mind.
No.
Never mind.
Okay? So does everybody follow what I did there? Whatever, depending on the angle I am, all right? The side that goes here is always the side across from it, and then you subtract everything else, yeah.
Does that have to be cos negative 1? You're looking for
Well, I'm not
negative?
there yet, because I'm looking for the cos of the, I'm looking for the ratio first. To find A, it has to be -1.
Okay.
Okay? All right, so I'm gonna work with that with Rory here. She's right. I got cos -1. Now, I need you to watch because this is probably going to be necessary for your keystrokes. So I go big bracket, little bracket. So what was across from the A? 20 squared. And then subtract the other two. 14 squared minus 15 squared. Like that. Over minus 2 times 14 times 15. Close it, close it. Okay? And then hit equals. Alright, so use your calculators now. Yes, Rory.
87.
You got the angle ready? 87 point.
134.
Okay. Punch it in, make sure you get the same value as Rory. Rick, you get it? Yeah? Gotcha. 87.134. Anybody not get it? Eli, you get it? Good. Alright? We okay? So, because I'm going to do B now. So if I'm doing B now, what's the first value?
14.
Which is it?
14 squared.
14 squared. And then you subtract the other two. What is it?
40.
Thanks. Okay? Again, at this point, once I have this first angle here, I could, in theory, use my law of sines. I could use my law of sines to do it, as long as I have one angle. All right? But I'm just working on the law of cosines just for practice. Okay? So now I want C. C is equal to, oops. Cos -1. And the side across from C is 15 squared. Subtract 14 squared, subtract 20 squared. Over minus 2 times 14 times 20. And that. What's wrong, Petra?
For B, isn't it?
Yeah.
44.36.
Yeah, that's wrong.
For this guy?
Yeah, it's 44.36.
Okay. Speak up, don't be shy. 44.1? I can't hear you.
36.
360?
Yeah.
Remember, I want 3 decimal places because I gotta use this again.
We'll actually then do 35, so
Do what?
44.357.
Okay. It's important that I use 3 decimal places. Because if I have to use it again, if I was using my law of sines, then I would have an issue. I would have been off by quite a bit. Okay? Yes, Eli.
I got 39.997.
For this guy right here?
Yeah.
That's what I got the first time I did it on my calculator.
You got that? Yeah?
Well, it rounded up to 998.
Okay, that's important to me. Gotta do that right. Okay, so now Eli, how do you check to see if your answer's right?
Yeah, that's the other one.
Okay, do it. Add the 3 together, what do I get?
I got 48 for this one. 48.50.
What'd you get, Eli? What, just tell me what you got. It's not right, is it?
Well, I added the 2 up and we got 127.
And then you gotta add it to the first one.
This one.
87.
Okay, what's the second one?
44.357. Sorry, I'll do this for you. Okay, so somewhere along the way we got an error. Why do I know I got an error?
They don't add up to 180.
They don't add up to 180. So which one of these 3 is wrong?
39.99.
This guy's wrong? Alright, what do we get for it?
I got like 48 something, so I really did it.
Say again?
48.509.
Now when you add them up, does it equal 180, Britt? Okay, so we got it right. So that's good. That's exactly what I need to see. Couple errors made. We checked it. We didn't get 180, so something had to be wrong. So then I go back and I fix the errors. Okay? Brandon, you saw what you needed to see?
Well, we kind of did this all for last.
Yeah.
Yeah.
All right, that's all I have for you today again. So you've basically got 45 minutes here today to work on 2.4. Were there any questions from 2.3 that was an issue? Any questions from 2.3 that you need to look at?
What did it mean by the on page 93? Like when it said make a flow chart or another bracket, there's another thing.
You can just read it.
Okay.
Okay, no, we don't need to do number 9. Were there any other questions in there? We're doing okay. We remember this from applied, those who were in it? Yeah? Okay, how about you guys? Are you okay on this? Yeah, have you seen this before?
Yeah.
Yes? Have you seen this before? So? No. Carolina, you haven't seen it before, has it? No? Okay, are you catching on to it? What about yesterday's work? Were you able to view some of the questions in? Okay, so if you have questions, circle it, tell me the question and the page number, we'll do it on the board, okay? So as you're working through this, okay? All right, you guys have the rest of today, if there's no other questions here.